All right, so let me give you the formulas you're gonna need. 6.1 graphs of, I believe it's called sine and cosine. Yeah. And cosine. So this is the general form. So given y equal to a sine omega x plus k, and y equal to a cosine of omega x plus k. Given these two, so this is just general sine and cosine with some number in front, some number inside. Let me see if I can generalize that further. Yeah, let me fix this because I changed it a little bit. Excuse me. Excuse me. So sine, and then inside the sine function, we have the omega times these. Technically, that's what we have. Let me go ahead and fix that. If you prefer, you could put like a bracket in here if you like that better. When you first start these problems, there's not going to be a b. It's just going to be the omega x by itself, and it'll be straight up. But after a few problems, it'll be more complex, and eventually you need to be able to factor the omega out, okay? So first thing we need to know is the amplitude for cosine and sine is the absolute value of A. So whatever number's in front, just make it positive. If it's already positive, then you're good. So when you ask for the amplitude, it's going to be that number here. Okay. Number two, the period for sine and cosine is 2 pi divided by your omega. Okay. We'll talk about that y in just a moment. Give you a second to write it. The phase shift for sine and cosine is that B right there. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Once it's been factored, it's gonna be B. Number 4, the vertical shift for sine and cosine is K. Double check something, sorry. Yeah, there's 2 ways to think about it. So if it's already been factored, then you just choose that number, B. Okay. If it's not factored, then it would be B over omega. Because factoring would cause that division. Do you see what I'm saying? Either way. It's the same thing. I'd rather you just think of it as factored every single time. And then whatever you have left over, they should. Okay, now let's talk about what those things are. But it's real quick. A, omega, B, and K are all real numbers. Should have said that earlier, but it's okay. It needs to be said. They need to be defined. Now, there's one more thing that the homework asks about. I think they call it the midline. Let's go look at that in a second. Come back to this. All right. So we can move this. You guys see this? Let's look at the example here. So find the amplitude and midline of the function y equal to 16 cosine 5x minus 7. So right away you should see that 16 and think, okay, well, whatever numbers in front, capital A, amplitude, right? That's what we said. And I'll show you graphically what that means. But for now, that's how you find it. It's just that number. Okay, so check it out. Oh, they do the midline first, but B, it's just gonna be that 16. Okay. I feel like their approach is a little more complicated, but it's not necessary. Just take that number. Okay. There's nothing the example might be more confusing than it needs to be. The midline is just gonna be that vertical shit. It's not right there. Yeah, you can calculate it different ways, but I don't know if that's necessary. Okay. Now you look at this one, number 2. What is the amplitude of this graph? Yeah, it's whatever number's in front. So 3 pi, right? Pi is just some number, who cares? Period. So this part we have to take the omega part. Okay. So we said the period is equal to, let me see if I can put the pencil here so you can use one screen. He said we'd take the number here and divide into the 2 pi. So it should be just 2 pi, oops. Divided by the 8. Which would be what? What is this as a reduced fraction? Yeah, it's gonna be power 4. Let me double check one thing. I don't have my, I'm gonna bring my books, I don't have my formulas. Does a minus sign matter? I don't think so. Let's find out. Oh man. Okay, you guys can see the stuff? Yeah. Output 2 was no big deal. Oh, yeah, not letting me do it. Okay. 5 pi. They changed it on me, but oh well. Period. Should be 2 pi over over 7. Let's see. Yeah. So we gotta make one subtle change on our formula. It's gonna be absolute value. Yes. Yeah, that's the part that I forgot on the formula that I would needed to check. So come back to our paper. This should be absolute. In the book, if you look at the book, it has the bars. I just couldn't remember. So when you factor, you only need to factor the positive. Okay. Midline is equal to okay. All right, so let's look at an actual graph here to see what this stuff looks like. It is very visual. Okay, so I recommend using Desmos grapher. It's really easy to use. For your homework, I'd recommend this. That way you don't have to buy anything. For an exam, I'm probably not going to give you graphing questions. I might just ask, what's the period? What's the phase shift? I'm not going to make you draw anything. Okay, but I will expect that basic stuff. I would like you to know what each graph looks like the originals. Cosine starts here using a unit circle. At 0, we have 1. Right? Look at the circle, -1, then 0. Over here, this is pi over 2. That pi over 2 closer to 0, so that's what it's at x equal to 0. At pi, it's -1. If you go around the circle, you have all these x numbers. Then once you get to pi, it starts over. Period meaning, how long does it take to cycle through and start over? 1 period is 2 pi, 0. 2 pi is about 6.2 or something, right? About here. If you have a number, this is the original cosine. Then now let's see, okay, well, what does a 2 in front do, right? We said that's called an amplitude of 2. Well, it stretches the graph up to now the lowest point, no longer -1, it's -2. Highest point is 2. So the amp is a bit amped up to, if that makes sense, distance from the center. What how do you do? Okay. That's how this number does. So I put a 4 in there, what do you expect? Right? You see where I'm going with this? All the rules that you did back in the day with graphs, like reflections and all that, is still in play from college algebra. If I do a -2, it still stretches the same way, but it's just going to be reflected. Right? Like the parabola, you remember? Yeah, x squared, negative in front, and just flips downward. Same thing. The original let's say I had positive. Oops. Damn fat fingers. Give me a second. Okay, let me block off the red because there's too much stuff going on. You can see how black is the original, negative is on the green one, so it's flipped up. So same stuff is still in play. Now, so that, does anyone have any questions on what amplitude is and how it affects the graph? Is that clear? Let me know if it's not. All right. So now let's talk about the period stuff. So if I put a 2 here, okay, let's choose a different color. All right, so the original is the red one. Cosine 2x is the blue one. What do you see? What is the change that you see? Comparing the original red to blue. What do you think? It's the same graph, but it's transformed, right? They are more narrow between the sure. On paper, when we said that we divide the period is divided by whatever that W is, right? The omega. Our omega is 2. So the original red graph here repeat itself every 2 pi. That was the original period. But look at the blue one. It repeats a lot sooner, right? So this 2 is cutting the period in half. Because you're going to do 2 pi divided by 2. That would be the new period. So essentially it's 2 times faster. So it's cycling through twice as fast. Right? So it's shorter period because it's twice as fast. It's covering that. It's repeating itself sooner. Does that make sense? So all that number does is make it cycle through quicker. Okay. It'll hit all the unit circle values sooner. So if I put a 4, let's compare this one to the 4. Right, just gonna keep going. Now you can do these things together. I can shorten the period, but also increase the amplitude, right, at the same time. So I could put the 2 here. But now it's been stretched out and sped up. This is true for sine. Sine is almost the same, except instead of starting here at 0, 1, it starts at 0, 0. Then it starts going up. You look at your circle. If you printed it out, cosine of 0 is 1, sine is 0 there, right? At 0, sine is 0, so it should be down here. So all these numbers are coming from your unit circle. At pi over 2, you get a 1 at 90 degrees. At pi, you get 0. That makes sense? Okay. So what I want you to be able to remember is, what does the original sine look like? What is the original cosine? Okay, and then just try to have notes for what do these numbers do to the original, right? Speed it up, stretch it out, etc. If I give you an equation, can you tell me the amplitude? That's what I'm gonna ask for in the exam. I'm gonna say, what's amplitude, what's the period, what's the phase shift? Okay. So all you need is this page I just wrote down. Excuse me. All right. On this question, they said, what is the amplitude? 5 pi, right? That's the number in front. Absolute value of -7 is 7, so it's going to be 2 pi over 7 for period. And midline is whatever's out here. 7. Midline is 7. Y equal to 7. You have to put that y equals part. Okay, because it's a line equation.
I have a question. Like, if there's no, like, for instance, in that example, there you have to just, so there's like an amplitude that automatically being stretched out, right? Or,
The 5 pi?
yeah. Or
Yeah,
that's
so-
in general, like, if there's an amplitude.
Yeah, so any number that's there greater than 1, it's gonna make it go bigger, stretch out.
And then for period shift, like, gonna make it go quicker, right? Around.
Yeah, if it's bigger than 1, yes. But if you have like a fraction here, then it's gonna shrink it.
Then it's bigger than, right?
Yeah, if it's greater than 1, then it will always stretch it. If it's a number between -1 and 1, then it'll be shrinking it down. Same thing for the period. If it's anything bigger than 1, it'll speed it up. Anything smaller than 1, slow it down. Oh, it's just a number in front. This case happens. You just write it down. Here it'll be 2 pi divided by the absolute value. And the midline is just that. This one is a negative within. That one does not have absolute.
I think you started off with a different question.
Yeah.
And then it changed.
Yeah, when I clicked it, it changed. So the original had a 3 pi. Anyway, let's see here. So the first few questions in your homework are the same thing over and over again. Changes here at phase shifts. So we said factor the number first. You're gonna have to factor 2 out of both of these. And whatever's left over on this number is your phase shift. Okay, so let's do that on paper. So this is example 1, problem 4 from the homework. I'll go ahead and open it, that way we can check ourselves. Oops. Give me a second. Excuse me. I don't know. Yeah, here we go. We'll use this one so we can check our stuff. Okay. Given that y is equal to 4 sine of 7x minus pi over 6. Part A, find the amplitude. Part B, find the period, I think. Yep. And C is the phase shift. All right, so the amplitude is no big deal, right? The amplitude is the absolute value of A, which in our case is the absolute value of 4. It's just still just a 4. But this would be your formula. Period is 2 pi divided by the absolute value of your omega, which is 2 pi divided by the absolute value of 7, which is 2 pi over 7. absolute value didn't make a difference, we'll just go ahead and write it just in case it's a negative. Like earlier, it mattered, right? Phase shift, we have to factor first. Or use this formula here. So you can do it this way. You take the pi over 6 and divide by your, oops, I said 6. Divide by your omega, be pi over 6 divided by absolute value of 7. So that's the way they do it in the example. What I'd prefer you do, just to get used to it, is write the equation down. I don't care how you do it, I'm just giving you advice. As long as it's legit, I don't care. Factor 7 from both. And when you factor something that has nothing in common with it, you have to just divide it. For example, let's say just real quick, you had 2x plus 3, and I wanted to factor 2 out of both of these terms, you would have x plus 3 over 2. Okay, so when I multiply it back, it would be the same. That's all we're doing. By stuff that you've done before. So this would be pi over 6 divided by 7, which is what this is. That's where it comes from. It'd simply be pi over 42. 7 times 6, 42. Is that right? I don't like numbers. So anyway, you can use this guy here, or just write this number down. That makes sense? Is that okay? You have any issues with this division of the fraction? Is that all right?
So basically, you just multiply 7. Is it?
Yeah, when you divide by a whole number, we had what, 5 over 6 divided by 7, that's the same thing as 5 over 6 times the reciprocal. Which is, yeah, and you end up with what you just said. 5 times 1, 6 times 7. So that happens here. And since there's no K out here, that they did not ask us about midline, right? They've been asking every single time, but this time they did not. Let's check our stuff. Yeah, 2 pi over 7. Cool. Pi over 42. They use decimals for some weird reason. I don't think it. I would use the fraction. It doesn't say what to round to. So give it the exact answer first. Any questions on number 1? Or the general idea? Make sense? And if not, let's do some questions and see if you get stuck. Let me double check before we stop here. Is there any weirdo questions in here? No, it's the same thing over and over again. 16 looks lame. Last semester, nobody could answer the 17. I'll hide those questions because the grapher in this program is kind of lame. It's difficult to use. I would recommend you graph them yourself on Desmos or calculator just to see what they look like, but they won't be questions. Okay, required questions. All right, we'll stop here. I want you to do some homework. And I'll take roll soon.